Alright, good morning viewers. Today we'll be looking at heights and distances on angles of elevation and depression. Okay, the question says the angle of elevation of the top of a house from the bottom of a tower 160 meter high is 26 degrees. Find the top of the tower. From the top of the tower, the angle of elevation is 24 degrees. What is the height of the house if the tower and the house are 50 meters apart? Find the distance between the top of the house and the bottom of the tower. Find the distance between the top of the tower and the top of the house. All right. So let's come back to the first instance there. It says the angle of elevation of the top of a house from the bottom of a tower is 160 meter. Sorry, bottom of a tower 160 meter high is 26 degrees. Okay, so we assume that this is the ground level. Okay, we assume that this is the ground level, and then we know that the house will be shorter than the tower. That is, the tower will be longer. Okay, so the tower will be longer than the house, and this is the ground level. So we can call this the tower. Okay, then we call this the house. Alright, then the question says that the angle of elevation of the top of a house, this is the top of the house, we can call the top of the house T, and we can call the top of the tower, R. Now we can call the bottom of this house X. We can call the bottom of the tower Y. Okay, so it says angle of elevation of the top of a house from the bottom of a tower 160 meter high. The tower is 160 meter high, so we take the height of this tower. The height of the tower is 160 meters. Okay, that is the height of this tower, 160 meter. 160 meter. Okay, so that is the height of the tower. I take note of that. Now it says it's 26 degrees. Okay, angle of elevation of the top of a house from the bottom of a tower is 26 degrees. So the top of the house from the bottom of the tower. So let's move. Okay, so from the bottom of this tower, the angle of elevation is 26 degrees. So take note, the top of the house from the bottom. So you are taking the angle from this point, from the bottom of the tower, is 26 degrees. Now from the top of the tower, which is this, from the top of the tower, the angle of elevation is 24 degrees. So I'll extend this, the house, extend it to the top of the tower. So from the top of the tower, the angle of elevation is 24 degrees. Okay, so that is it. So from the top of the tower, the angle of elevation is 24 degrees. While from the bottom of the tower, the angle of elevation is 26 degrees. Alright? Okay. So it says from the top of the tower, the angle of elevation is 24 degrees. Now, what is the height of the house if the tower and the house are 50 meters apart? What is the height of the house if the tower and the house are 50 meters apart? So they're asking us to find the height of this house. What is the height of this house? I can say let the height be small h. The height of the house is small h. If the tower and the house are 50 meters apart, so distance between this house and the tower is 50 meters. Distance between the house and the tower is 50 meters. That's the distance between the house and the tower. Distance between the house and the tower is 50 meters. Alright. Okay, so let's come back to this. If this is 26 degrees, of course, if you use dotted lines, extending this to this, you know that 26 degrees here we alternate here as 26 degrees. Alternate angles. So this is 26 degrees. And you can use dotted lines to extend this one. Okay, use dotted lines and extend it. So you find this other angle. Find the angle. This is 24. So 90 minus 24. 90 minus 24 degrees. That will give us okay, that's 66. That will give us 66 degrees. Okay, and this 66 can alternate. If this is 66, it will alternate here at 66 degrees. Okay, alternate angles. So 66 degrees will alternate here at 66. Then I can then add the total angle here. That's 66 plus 26. Okay, so that will give me 92 degrees. If I add it, it gives me 92 degrees. Okay. Alright, so you can also choose to find this inner angle here. You can find that angle there. That will be 90 minus 26. Okay, because this full angle, the full angle here is 90 degrees. So it's complementary angles. So this is 26 now. Here will be 90 minus 26. This side, 90 minus 26 will give us that should be 64 degrees. Okay. Alright, so we have gotten that angle. So those are the basic angles we need. Okay. So 26 will alternate here as 26. And 64 will alternate here as 64 degrees. Here is 64 degrees. Okay, and here is angle 90. Here is 90 degrees. Okay, so that's the diagram we're having. Alright, so that's the diagram we're having. This one shows you the house, and this one shows you the tower. And those are the angles there. Okay, distance between the house and the tower is 50 meters, and the height of the tower is 160 meters. Okay, so that's the diagram. You must draw the diagram correctly before you start solving. Okay, so the next thing they say we should find is the height of the house. It says, what is the height of the house if the tower and the house are 50 meters apart? To find the height of the house, you have to section this triangle TYX. So you say from triangle TYX. So if I section that triangle out, I will have to cut it out, and I'll have this. So the angle at this point is 26 degrees. It's 26 degrees, and here is 90 degrees. Here is H. Distance from point X distance from point X to point Y is 50 meters. Okay, we had this other angle as 64 degrees. So let's assume that we are making use of this angle. So assume we are making use of this angle. So if I'm making use of that angle now, I can clean this one out. I don't need it. Making use of this angle, I can say this is opposite. This side is opposite to this angle. So this side is opposite to this angle, and then here will be adjacent to it. Now the hypotenuse side now is here. Okay, it's hypotenuse because it is facing 90 degrees. Okay, so mind you, what we took was the triangle TXY. We just sectioned it out. Triangle TXY, if we cut it out like this, this is what we're having. What we have, okay? So now if we have the opposite side and then the adjacent side, so you make use of tangents. That's tan 26 degrees equals to the opposite over the adjacent. Okay, so you say tan 26 will be the opposite side is distance tx, and my adjacent side is xy. All right, so that will be okay. So this now will be tan 26 and 26 degrees will be equals to distance tx is h, the height of the house, and xy is 50 meters. So if I cross multiply, I have that h is equals to 50 tan 26 degrees. 50 tan 26 degrees. So H will be equals to 50 times, look for tan 26 on your calculator, you have, so I'll be having 0.488. If you will multiply it now, H will be equals to 50 times 0.488. I'll be having, it will give me 24.4 meters. 24.4 meters, that's the height. Okay, so the height of that house is 24.4 meters. So therefore, the height of the house, the height of the house is 24.4 meters. Okay, so quickly I will just explain what I did. This is the diagram. I had to cut out triangle TYX. So when I sectioned this triangle, I was able to obtain the height of this house. Of course, this is the height, the house. Distance TX is the house. So when I cut it out now, I say from triangle TYX, this is it. This side facing the angle of inclination 26 degrees is the height, is the opposite, sorry. The opposite side is the one facing the angle of inclination. Then the side facing the angle 90 degrees is the hypotenuse side, and here now becomes the adjacent side. Okay, so using your trig ratio, the basic trig ratio, which is so we made use of this. Okay, so 2 and now tells us the tangent of an angle is equals to the opposite side or divided by adjacent. So I say tan 26 degrees is equals to opposite of adjacent. Okay, so tan 26 will be equals to the opposite side now is this side, tx, and the adjacent side is xy. So that's tx over xy. Okay, that is this from here to here divided by what? Xy. Okay, so that now will be, this now is tan 26 equals to h over 50. That's the opposite side. Distance tx is h, and the adjacent side is what? Is 50. That's how I got this h over 50. That's from here, h over 50. Alright, so that is it. So if I cross multiply this will multiply this, that gives me 50 tan 26 degrees. So tan 26 is 0.488. I multiply it with 50, I have 24.4 meters. That's the height of the house. Okay. Alright, so the next thing they say we should find is the distance between the top of the house and the bottom of the tower. Okay, distance between the top of the house and the bottom of this tower. That is distance ty. Distance ty. So to find the distance between the top of this house and the bottom of the tower. So what you do now is to section this portion of the triangle. Okay, then find ty. It's as simple as that. Okay, so you can say from triangle TXY, from triangle TXY, we're having something like this. Here is 26 degrees. Okay, and here is 90. This is point T, point X, and point Y. And mind you, what we are looking for is distance ty. Distance ty, which is the distance between the top of the house and the bottom of the tower. Okay, now we had this point as 50 meters, isn't it? And we have already gotten the height as 24.4. Now, but what you are looking for is this. Now, the side that faces angle 90 degrees is the hypotenuse side. The side facing the angle of inclination is my opposite. Now, the remaining side now becomes what? My adjacent side. Okay? It then implies that to look for this hypotenuse side, I will make use of car. Let's make use of car. That is, car shows you, it tells you that the cosine of an angle is equal to its adjacent side over the hypotenuse. Okay, that's the meaning of car. So it shows you that the cosine of an angle is adjacent to the hypotenuse. This one is so shows you, say sine of an angle is opposite of hypotenuse. CAR shows you that what the cosine of an angle is what? Adjacent of hypotenuse. Why TOA? TOA means the tangent of an angle. Tangent of an angle is what? Equals to the opposite side over the adjacent side. So let's make use of this. Okay, so making use of that now, I'll say that cos 26 degrees is equals to adjacent over the hypotenuse. My adjacent side is this 50 meter, which is distance xy. Distance xy. And my hypotenuse is distance ty. Distance ty. Okay, so I put the value of xy there, which is 50 meters. I put the value of that and have 50. So I have cos 26 degrees is equals to 50 over ty. Over ty. So that is xy, distance xy. Xy is what? 50 meters. So if I then cross multiply, I can cross multiply that, or I can choose to just interchange positions. By interchanging positions, now I have, if I interchange their positions, I'll have ty is equals to 50 over cos 26. So what I did is just to interchange positions. I carry this one here, then carry this one here. That's 50 over cos 26. So that means that distance ty is equal to 50 divided by cos 26 will give me okay, so cos 26 will give me 0.8987. okay, that is it, 0.8987. So this implies that distance ty will be equals to 50 divided by 0.8987. That is this will give me 55.64 in meters. Okay, all right, I have 55.64. So therefore distance between the top of the house, distance between the top of the house and the bottom of the tower is 55.64 meters. Okay, that's two decimal places, 55.64 meters. All right, so that is it. Okay, that is it. Now let's look at the next one. The last one there, it says find the distance between the top of the tower and the top of the house. Find the distance between the top of the tower and the top of the house. Okay, top of the tower and the top of the house. All right, let's go back to the diagram. Okay, so the top of the tower is this arrow and the top of the house is a T. So we are going to look for the distance between the top of the tower and the top of the house. That is distance T arrow. And how do we find this distance T arrow? How do we find distance T arrow? Now what I'll simply do is to actually cut out this triangle. I'll cut out the triangle T arrow Y. I'll cut out triangle T arrow Y. Then I'll find that distance. Okay, quickly let's solve that from triangle T arrow Y. Okay, now I'll say from triangle T arrow Y, that is from triangle T arrow Y, I'll have something like this. T arrow and Y. Okay, so the angle here is 92 degrees and this angle here is 24 degrees. Angle here is 64 degrees. Okay, now remember that we have already gotten ty. We had distance ty as 55.64. We had distance ty as 55.64 meters, and then we are given distance ry. Distance ry is the height of the tower. It's 160 meter from that diagram. Distance ry is 160 meters. So that is it, 160 meter. Now what we are looking for is TR, distance TR. Okay, so this is capital R, if this point is capital arrow, this side that faces capital arrow is small arrow. Okay, this is capital T. The side facing capital T is small t. So this side is capital Y. The side facing it is small y. Okay, it's small y. So now we can then solve it now using sine rule. We can make use of sine rule in solving that. So using sine rule, I'll say that sine. So using sine rule, I'll say sine t over small t is equals to sine arrow over small arrow is equals to sine y over small y. Okay, so angle at t is 92. That's sine 92 degrees over small t is 160 equals to sine angle at arrow is 24 degrees. Small arrow is 55.64 is equals to sine angle at y. Angle at y is 64 degrees. And small y is t arrow, distance t arrow. Okay, so I'll come back again to that diagram. Sine t over small t, angle at t, that is this t here. Angle at t is 92 degrees. So the angle at point t is 92 degrees. So I'm having, in place of this t now, write what? 92, that's sine 92. Small t is 160 meters. 160 meters, so that is this. In place of this small t, I write what? 160 meters. Now, angle at arrow, sine arrow over small arrow. Angle at arrow, you come here. Angle at arrow is what? 24 degrees. And small arrow is what? 55.64. Okay, that's 55.64 meters. Alright, that's small arrow. So, angle at arrow is 24. That's sine 24 over small arrow is what? 55.64. Then look at sine y. Angle at y is 64 degrees. 64 degrees. And small y is what? Is t arrow. So that will be sine 64 over distance t arrow. Alright. So we can then compare each of them. Compare this to this and compare this to this. That will be sine 92 over 160 is equals to sine 64 degrees over distance t arrow. Okay, so let's see what we get. We then cross multiply. If I cross multiply, this will multiply this. Why this one multiply this one? So I'll have what? Distance t arrow times sine 92 degrees is equals to, this will multiply this one, 160 times sine 64 degrees. So that means this will give me t arrow sine 92 equals to 160 sine 64 degrees. Abi? Now divide by the coefficient of t arrow. The coefficient of t arrow is sine 92. That means distance t arrow will be equals to 160 sine 64 degrees divided by sine 92 degrees. Okay? So it means that distance t arrow will be equal to 160 times, now look for sine 64. In my calculator, I'll be having, that is 0.8988 multiplied by sine 92 will give me, that is 0.9994, which is sine 92. 0.9994. Okay, so distance t arrow now will be equal to, if I multiply this, 160 times 0.8988, that will give me this will give me 143.808 divided by 0.9994. Okay, so if I divide this now, we're having I'll be having 143.89 meters. That's distance t arrow. Distance t arrow is 143.89 43.89 meters. Okay, so I made use of sine rule, and that's what I had using sine rule. These are our procedures. Okay, that's the procedure. So I had to compare this with this. Then I can still use this, compare this and this, then make TR a subject of formula. I will still get my answer as 143.89. okay, so you have to be sure of what you are doing. So I had to compare this with this, make TR a subject of formula, or I can compare this and then solve and get my answer. So finally I arrived at 143.89 meters. Okay, so take notes. This is the actual diagram. We have to section here out so that we can find the distance between the top of the house and the top of the tower. So distance between the top of the house and the top of the tower is what we just found now. That is 143.89 meter, which is distance TR. Alright, okay, thank you. That's the end of this question. Thank you very much. Alright, we have another question on the board. It says the boy is standing 70 meters away from a flag post, observes that the angles of elevation of the top and bottom of the tower on top of the flag post are 57 degrees and 69 degrees respectively. Find the height of the tower. Okay, so let's assume that this is the ground level. We assume that this is the ground level. Okay, and then at this point we have a tower. We have a tower at this point. This is the tower. And then this is the flag post. Now the boy is standing at this point. The boy is at this point. We can call this boy X. And he's 70 meters away from the flag post. So distance between the boy and this flag post is 70 meters. So distance between the boy and the flag post is 70 meters. He's 70 meters away from the flag post. Okay. Now this is the tower. Okay. This is the boy. At this point you have the boy. At this point you have the boy. And this is the flag post. Okay. Alright. So they said he observes that the angles of elevation of the top and bottom of a tower on top of the flag post are 57 degrees and 59 degrees respectively. So the angles of elevation of the top is 57 degrees, and then the bottom is 69 degrees. Okay, quickly let's do that. So this is the top. You can say the top of this tower is T, and then we can call the bottom arrow. Okay, so he observed that the angle of elevation of the top of that tower, the angle of elevation of the top of the tower is 57 degrees. And then he also observed angle of elevation of the bottom of the tower. He observed that the angle of elevation of the bottom of the tower is 69 degrees. Okay, this is the boy. He's the one that is observing. He's the observer. This young man over here is the observer, and he observed that the angle of elevation of the top of this tower is 57 degrees. And then he also observed the angle of elevation of the bottom of the tower is 69 degrees. Okay, alright, that's it by the way. So we can then extend this. If I use dotted lines, I can extend here now using dotted lines. Okay, so we are aware that this is the boy. This point is the boy. So if this is 57 degrees, here is also what? We can find there now 90 minus 57. 90 minus 57, we get this side. Okay, that will give me 33 degrees. Okay, that's it. 90 minus 57, that's 33 degrees. So then if here is 57 degrees, you can come here now. This is 57 degrees. This will alternate here as 57 as well. Okay, and if here is 33 degrees, to alternate here as 33. Okay, so 57, we alternate here as 57. and 33. We alternate here as 33 degrees. Okay, so here is 69 degrees. We can find this angle. We can find this other angle. Okay. So you can find this angle. That would be 90 minus 69. 90 minus 69, you will have this angle here. That would be, okay. So this side now is 21 degrees. Here is 21 degrees. 21 degrees. Okay. So if here is 69, here will be 21. You know, this is it. This is it. If here is 69, then this side will be what? That's 90 minus 69. We give you 21 degrees. As I got this 21 degrees here. Okay. Why this other one now? Here is 57. Okay. So here now will be 90 minus 57. Here will be 33. As I got the angles. Okay. Now we then add these two. Add these two angles. 57 plus 21. That will give me 78 degrees. Okay. And I add these two. That's 78 degrees. So if this is 21 degrees, this will alternate here as 21. That's 21 degrees. This one is alternate to this angle. Okay. So that's 21, 21, alternating 21 there. So if here is 69, then it also implies that here is also what? 69. Alternate angles. Alternate angles, 69 degrees. Okay, so that is it. All right, so that's what we're having. That's the diagram we're having. Observe clearly. Now they say we should find the height of the tower. How then do we find the height of this tower? The height of the tower. Find the height of the tower. Okay, so quickly let's find the height of the tower. This is the tower. So the height is distance from here to here. You can call this h. So distance from point T to point R is the height of the tower. Okay, so how then do we find it? We the first thing we do now, we can cut this section out. Cut this triangle out. You say from triangle. Remember that this point is point X. Here is point X. At this point X, and this is point T. Here is point R. Then we can call here Y. I say from triangle. From triangle X arrow Y. From triangle X arrow Y. Now that is from here to here to here. Triangle X arrow Y. If I cut it out now, okay, observe that if I cut X arrow Y out, I'll have that is X, Y, and arrow. Okay, this angle here is 21 degrees. Okay, and then here is 90. That's here. At this point, you have angle 90 degrees. Okay. Then distance from here to here is 70 meters. Now let's then look for this side. I can find this portion. I can say this portion from here to here. I can call it Y. Y. Okay. Now the side facing angle 90 degrees is hypotenuse. The side that faces the angle of inclination is opposite. Then the remaining side is what? Adjacent. Okay. The remaining side is alright. So if I'm to obtain the hypotenuse side, you use the basic trig ratio. If this is the hypotenuse and then this is opposite, we use the sine of an angle. That is, you say so quatoire. So making use of so. Sine of an angle is the opposite side over the hypotenuse side. So I'll say sine 21 degrees is equals to the opposite over the hypotenuse, which is the opposite side is distance xy, and then the hypotenuse is distance x arrow. Okay, so the opposite side is xy and the hypotenuse is x arrow. Okay, so that now will give me, this will be equals to xy is 70 and the hypotenuse is xr, which is small y. So as distance xy is 70 meters and my hypotenuse is xr, which is y meters. Okay, so now I'll be having a sine 21 equals to 70 over y. That's sine 21 equals to 70 divided by y. So if I then interchange position, I'll be having y equals to 70 divided by sine 21 degrees. Okay, so y will be equals to 70 divided by sine 21 will give me, so this will give me 0.3584. Okay, so y will be equal to, when I divide it, I'll be having when I divide, I'll be having 195.31 meters. Okay, so there's 195.31 meters. That's distance from here to here. Okay, that's the distance from point X to point R. Is this? Okay, from X to R, I've gotten that here. So therefore, distance xy, xr rather, distance xr is equals to 195.31 meters. Okay, 195.31. That is it. Distance xr is 195.31 meters. Distance from X to R is that. Okay. So now to find the height of that triangle, to find the height of the tower rather, I will cut out triangle XTR, triangle XTR, so that I can find the height of the tower. So I'll cut that triangle out. So from triangle XTR, I'll have, so I'll say from triangle XTR, I'll be having something like this. Angle at this point is 78 degrees, and here is 69 degrees, here is 33 degrees. This is point X, this is point R, and this is point T. Okay, and then we have already gotten distance XR. We got distance XR as 195.31 meters. And what you're looking for is what? Is small h. That's the height of the tower. Alright? So if this is capital X, the side facing capital X is small x. If it's capital T, the side facing capital T is small letter t. If this is capital letter R, the side that faces it, this side here becomes what? Small letter r. So that we can make use of sine rule. So we make use of sine rule and then we'll obtain the height of the tower. So using sine rule, I'll be having, using sine rule now, I'll be having sine x over small x is equals to sine r over small r is equals to sine t over small t. So angle at x now is 78 degrees. That's sine 78 degrees over small x is h, which is the height. Okay, that is it. Angle at x is 78, then small x is h, the height. I'll come back again, sine r, angle at r, come back to the diagram, angle at r is 69, and this is small r. Angle at t is what? 33, and small t is 195.31 meters. Okay, so I'll come back again, sine r, angle at r is 69 degrees, that's 69 degrees over small r is unknown, equals to sine capital T, angle at t is 33 degrees, and small t is 195.31. Okay, So what I need now is this and this. I'll compare these two. I'll neglect this other one, neglect this. So since I'm looking for the height now, say sine 78 degrees over small h is equals to sine 33 degrees over 195.31. Okay, so I can then cross multiply and I'll have, we're having this times this, this times this, that will be h. If I cross multiply, this will multiply this, that will be h sine 33 degrees equal to, and this one will multiply this one, that's 195.31 sine 78 degrees. Okay, alright, then if I make h subject of formula, I'll be having h equals to 195.31 sine 78 degrees divided by sine 33 degrees. Okay, so this will give me, should be equals to 195.31 times, that is, I'll use my calculator, using a scientific calculator, find the value of sine 70. This will give me 0.978. Then I can find the value of sine 33. That will give me, this will give me 0.545. Okay, now multiply this and then divide by the answer here. That will be, okay, so when I multiply this now, this times this, I'll be having 191. That will give me 191.013 divided by 0.545. So when I divide it now, I'll be having so this will give me 350.48 meters. Okay, so you say therefore the height of the tower is 350.48 meters. 350.48 meters. 350.48 meters. Okay, so observe what I did. This is the height. We have gotten the height of the tower as this. This is everything we did using sine rule. Finally, we arrived at this. We cross multiplied. We made h subject of formula. This we multiply. This one multiply this one. So we had h times this is h sine 33. This times this one is what? 195.31 sine 78. So when I now divide by the coefficient of h is sine 33. Divide by sine 33. Now I have what? 195.31 sine 78 divided by sine 33. Now using my scientific calculator, I had sine 78 as what? 0.978. Multiply it with 195.31. I had 191.013. So sine 78 is this. Multiply with this. Then sine 33 is 0.545. Now when I multiply this and this, I'll have 191.013 divided by 0.545. I have 350.48 meter. That is the height of the tower. The height of the tower is 350.48 meter to 2 decimal places. To 1 decimal place will be 350.5, and to the nearest whole number will be 350 meters. All right, thank you very much. Okay, so observe, this was the diagram. So the diagram, this is the height of the tower. We have gotten the height of the tower as 350.48 meters, and then this is the distance between the buoy and the flag post, 70 meters. So we have solved everything. We have gotten the answer. Okay, we've gotten the answer that we need. This is it. Okay.